Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 10 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 712. Minimum ASCII delete sum for two strings. So in this problem you are given two strings S1 and S2 and you have to return the lowest ASCII sum of the deleted characters to make two strings equal, right? So here if you see example number 1, so from this example, if I delete S from here and if I delete T from here, so now see S1 is EA and S2 is EA, right? Both are matching, right? Both the strings are equal. So here I am deleting S and in this side I am deleting T, right? So what is the ASCII value of S is 115 and what is the ASCII value of T? It's nothing but 116, right? So if I just add these two, so I will get here 231, right? And 231 is the output. That's it. Clear? Same way here if you see example number 2, right? So if I delete D from here, E from here and this E from here, and same way if I delete this E from here, right? So now here we have LET and here we have LET, right? So both the strings are matching, right? So what I'm deleting? I'm deleting D, right? D ASCII value is 100. I'm deleting E one time, ASCII value is 101. Here I'm deleting E one more, right? So here again 101 and from this side again I'm deleting E, right? So here one more 101. So overall I'm getting 403. So 403 is the output. That's it, right? Okay, now let's see how we have to solve this problem, right? So if you see here, we are just deleting the characters and we are making sure, right, that we will get the longest common sequence, right? Longest common subsequence, right? So this type of problem is little bit similar to this longest common subsequence, right? So here matching, right? Here this string EA is matching, here this string EA is matching, right? Why I'm saying longest? If I delete E from here, if I delete E from here, again both the strings are matching, right? But we have to return the lowest ASCII sum of the deleted characters, right? So lowest number of characters I need to delete, right? So I don't need to delete this, okay? As soon as the strings are matching, right, with the longest common subsequence, I'm good, right? So here this type of problems, right? So like if I'm starting from here, let's say I and until end, right? And here also let's say I'm starting from my J here and until end. So from I until end and here from J until end, right? I have to iterate in such a way so that I can delete the minimum number of characters and make two strings equal, right? This is what I need to do, right? So in last 2-3 days, I think we have solved some similar kind of problem, right? In which we were doing the same thing, right? DFS of I2 and J2 end, right? So same logic I'm going to apply in this problem, right? Okay, so let's see this example number 1, SEA, C and EAT. Okay, so let's do the dry run here. Okay, first S1 is equal to C and S2 is equal to EAT, right? And here if I just give the indexing here, 0 index, 1 index, 2 index, same way here 0 index, 1 index, 2 index, right? Clear this part? And let's say your I is here initially and here let's say your J is here. Clear this part? So now I am starting from 0 and this 0. This is nothing but my I and this is nothing but my J index, right? Okay, so now here see, here we have S and here we have E, right? Both the characters are not matching, right? They are not matching. So definitely here I have two options, right? If I can delete S here and move my I to the next position, this is one option, right? Or I can do one thing, here in this side I can delete this E, right, and move my J to the next position, right? So total two choices I have here, right? One is if I am deleting this S, so I can say S S1 dot character at I. Okay, character at I am deleting. Okay, let's do one thing. Let's write it simple, right? Let's keep it simple. So here I'm deleting this, right? S. So what is the ASCII value? Is 115, right? 115. So I am deleting this 115 S, right? S I'm deleting 115, and after that my DFS is going to move forward, right? This I is going to move forward. So I plus 1 and J is going to remain at the same position, right? This is one option. Or I can do one thing here. I can delete this E, right? What is the E ASCII value? E ASCII value is 101, right? 101 plus, next I am going to call this helper method DFS, and this time my I is going to remain here itself. My J is moving forward, right? J plus 1, right? Clear this part? Okay. Now I can write this as this part I plus 1, right? I plus 1. So I can write it like this now. DFS of I is 0. Now my I is moving forward, right? Here at 1 index, and J is 0, right? At 0 only. Same way here, I can write it like this. DFS, I is remaining same here, 0 itself, right? And J is incrementing by 1. So here 0, 1, right? Clear this part? Okay. Now after that, I need to solve this now. Okay. Now here, if you see in this side, let's see this subtree now. Okay. So in this side, if you notice, my I is at 1 index, right? My I is at 1 index here. My I is here, and my J is at 0. Okay. Now see, this character and this character both are matching, right? Both are matching, right? This and this. Now I don't need to delete, right? I don't need to delete. So I am going to simply move my I forward here, and in this side I'm going to move my J to the next position, right? I don't need to delete, right? Both E and E are matching. So I can say, I can write it like this now. DFS of I am moving forward, right? So here it is going to become 1 plus 1, 2, and here J is moving one step forward. So here 1, right? Because I don't need to delete this 1, 0, right? Here. Okay, both are matching. Done. Done. Okay. So now again, if you notice here, this and this both are matching, right? Both are matching. Again, I'm going to move my I forward, right? I don't need to delete any of these, right? Both are matching. Why should I need to delete, right? I have to take it. So here my J is going to move here, right? Clear? My J is going to move here now, at 2. Okay. And my I is here moving out of bound, right? If you see. So here again, I'm incrementing DFS. This is 3 and this is 2. All right. So now, if you notice here, if you notice one thing here, that your I goes out of bound, right? I goes out of bound, right? And here J is at 2 index, right? So now in this case, if you notice, uh, I goes out of bound and here J is here, right? So I can't compare this I with J, right? Because I already goes out of bound, right? I already goes out of bound. So I have checked everything in my S1, right? But in S2, my J is still at T, right? So let's do one thing now. I don't need to check this also. Let's remove it because I am not going to compare this with anything, right? So here I have to delete this T, right? This T is the extra because I is completed, I is out of bound, right? And here these are the extra left out part. Okay, this is the left out part, right? Whatever number of characters we have right now, only 1, right? So I have to delete all these. So here in this side we have just T, right? So what is the T's ASCII value? T ASCII value is 116. So I'm going to delete T right here. That is nothing but 116. So overall here I'm deleting S and I'm deleting T. So 115, 116. If you add, so you are going to get what? 6, 7, 8, 9, 10, 11, right? Here 3, 231. You are getting 231, right? 231 from this side. Okay, 231, right? 231 is my output or not? Yes, right? So this is correct, right? Here I'm reading S and from this side I'm reading T. Okay, so this is how you need to solve. Okay, let me show you this subtree as well. Okay, Now here if you notice, again let me do one thing. Okay, let me just remove this and this right now. Okay, now here see, my I is at 0 as of now, and my j is at this particular position, right? This one, right? If you see, now here s and here we have a, right? Both are not matching. Again I have two options here, right? So maybe I delete s, right? So this 101 is of when I was moving from e, right? 101 is of e, right? So here e. Now here my j is here, my I is here at s. Now let's suppose 101, that is e, plus let's suppose if I delete this s, so s is nothing but 115. I'm deleting s, right? And then after this I have to solve the remaining portion, that is nothing but I is moving forward, right? I plus 1. So I plus 1, and j is going to remain here itself, right? This, or here 101 is coming from top, plus 100. I'm moving, let's suppose this a. Okay, I don't need this a is ASCII values 97, right? Okay, so here I'm going to write 97. Okay, so here 97 I'm deleting for a, and then after that I'm going to move forward. So I is going to remain here only, and j is going to increment. Okay, these are the two options I have, right? So now again I have to solve these two parts now, right? These two parts, right? So here what you need to do, I can say that this is nothing but, what is the value of this one? I can say it is nothing but dfs of 0 plus 1 1, and j is same. Okay, and what is this value? This value is nothing but dfs of I from top, and j is 2. Okay, this, now I have to solve this, right? So here overall this one, let's calculate the sum, right? 101 and 115, that is nothing but 61216, right? Here this is nothing but 216, so 216, right? 216 plus this, and here 101, and here this 97, that is nothing but 891. Okay, so 198 plus this, these two things I need to solve now. Okay, so now let's see this part now. Okay, so 1 comma 1, right? 1 comma 1, that is something what I am here, my I is here, and my j is here. Okay, at 1, right? J is here, right? Okay, so now again here see, e and a, so again both are not matching, so again I have two options here, right? Again I have two options, right? So one is 216 plus one is if I delete this e, right? Clear? One is if I delete this e. So if I'm deleting e, so I'm going to get 101 here. Okay, 101. Then after that, I'm going to call, I'm deleting this e. So my I is going to move forward, right? So here it is going to become 2 comma 1, right? 2 comma 1, only I is updating with 1. Okay, I have two options, right? This 216 plus 101, and then dfs of 21. Okay, this is one thing. Same way here also I need to write two things, no? Two things I need to write here. Same way for this one, again you have two options, right? So 216 plus, if you delete e from here, so that is why you are writing 101, or if you write a, so 216 plus 97, right? Plus then dfs of here, it is going to become 1 right? Now j is moving, you are moving j, that is nothing but 1, it is going to remain same, and here it is going to become 2, right? So like this actually you need to move forward, right? So this is what you need to do, right? So again here also you have to try different possibilities, then in the end whatever the lowest value that you have, that's what you need to return to do a dfs of 0 in the end. Okay, from here you have to return something, you have to return something, from here you need to return something, from here you need to return something. Okay, from here you need to return something, here you need to return something. So whatever the minimum value that you are going to return finally to here, and that's what you need to return. Okay, so this is what you need to do, right? So this tree is going to be very big. Okay, that's why not moving forward like this. But see, from this branch I think you will get the best result. Okay, same way here you will get something, you will get something like this. Only you need to solve, right? So now let's write the code for this. So this is nothing but your, we are moving from top, right? So here this is nothing but your top down approach, top down DP approach, that is nothing but recursion. Okay, recursion. And I will also implement the memoization in this part. Okay, memoization in this part, right? So because here maybe here when I'm calling some value, right, from this tree I am going to solve, right? And there may be some matching values I will get, right? Maybe I have already solved this part of a tree in here in this side, right? So I don't need to solve that tree again and again. So only two values are changing, I and j, right? So if I have already solved this part somewhere here, then I don't need to again form the tree for this. I will directly return the answer. So that is the purpose of memoization, right? Now let's write the code for this, right? Very simple. Then once this is done, then after that I will move to the next approach, bottom up, right? That is nothing but in which we will just use the DP, okay, tabulation method, right? So let's write the code with this. Very simple. Okay, nothing complex here. So what you need to do here, first thing, take two strings, okay, string s1 and s2. Okay, I am writing this in the class level, right, so that I don't need to pass them in the helper method. Okay, whatever the helper method I'm creating, right? So now we can access them globally, not inside just one method, right? In this class we can access globally. All right, so here I'm just going to write this dot s1 is equal to s1, this dot s2 is equal to s2, right? And here int n is equal to s1 dot length, and same way m is nothing but s2 dot length, right? And then you have to just initialize the memo is equal to new int, and here you have to write n and m, right? And here you have to initialize memo with -1, right? Uncomputed. That simply means I'm saying if it is -1, that simply means let's say it is uncomputed. Okay, so here what I will do, for int I is equal to 0, I is less than n I plus plus, and here I will update arrays dot fill memo of I value, right, of this complete I will just fill with -1, right, for this complete row, right? So this is what I'm doing here, and from here I'm just going to calculate return DFS of 0, I is 0 to end, and j is from 0 to end in s1 and s2 respectively, right? So this is the basic thing, right? So this same thing I think we did in one question 2-3 days back, same thing, right? I'm going to do the same thing here. I will, okay, I will add that problem in the description maybe, okay, of this video, right? So here I will do one thing, private int dfs, and here int I and int j, and here now I told you that if s1 base case I'm writing, if s1 exhausted, right, x1 is completed, right, s1 goes out of mode, then we have to delete remaining characters in s2, right, remaining s2, right? So here I'm just going to write if I is equal to s1 dot length, right? If this is the case, then what you need to do here, take int sum is equal to 0, and then here you have to run one loop int and here let's say k is equal to j here, and k should be less than s2 dot length, right? Because from s2 we need to delete the characters, right? And here k plus plus, and here sum is equal to sum plus here s2 dot char at k, right? Done this thing, and from here I will return the sum value, okay? This is clear, right? Now this same thing base case I need to write for s2, okay? If s2 is exhausted, then we have to delete the remaining s1, right? So here if I'm going to write if your j is equal to s2 dot length, then again I'm creating a sum variable, and k this time I'm going to iterate from I, and in s1 I will iterate, and here same thing, and here sum is equal to s1 dot char at k, and from here also I'm going to return sum. So these two are the basic things that we did, right? And here one more thing we will check if we have already solved this subtree in the past or not. So if memo of I and j value, right, if it is not equal to -1, that simply means it is computed in the past, right? So we will just simply return the value of memo of I and j here, right? Now here very like this you part already know, right? I explained it, right? So if the characters are matching, then no need to delete, right? So is if s1 dot char at index I, right, if it is equal to s2 dot char at index j, right? In this case what you need to do, okay, if this is the case, then you have to update your memo of I and j with just move forward, right? So in DFS I'm just going to pass I plus 1 j plus 1, that's it, right? Okay, now in the else part what you need to do if both are not matching, so you have two options, right? If int delete s1, right, this is what you can do. So in this s1 dot char at index I, and then you are deleting from s1, right? So here dfs of I plus 1 and here j, that's it, right? Same way if you can, you have other option, one more option, right? You can delete from s2. So int delete from s2 is nothing but you can say s2 dot char at j, right? And here dfs of I, and here in this time you have to write j plus 1 here, right? That's it. And after that here you have to update your memo of I and j value as minimum of, right, math dot min of what, this delete s1, right, and here delete s2, right? This is what you need to do, right? And whatever the memo of ij value you are going to get, right, here you have to finally return that, okay? Return memo of I and j value, right? This is what you need to do, that's it, okay? This is your code, right? Now let's run it. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? Okay, and the time complexity is going to be of m into n because we are using memoization, right? If we don't use memoization, then for every place we have uh, three choices, right? If you can see here, if I can skip from s1, or if I can skip from s2, or if I take both, right, if no characters are matching. So then in that case we have not m into n time complexity, right? But since we are using memoization, so we are checking all the states only once, so we can say time complexity is of m into n, right? Clear? Now we are going to see the bottom up approach, right? So in bottom up approach, what I'm going to do here, let's take the example 2 this time, right? So you have this delete and this lead. Okay, so ASCII values of all these are this, and the length of this is 6 and this is 4, right? So DP definition we will take, that is nothing but minimum ASCII delete sum to make S1 I to end, S2 J to end equal, right? So we are going to fill the table bottom up, right? Okay, so here first base case is nothing but, so let's say last column j is equal to 4 means S2 exhausted, right? So if your j is here, right, 0 1 2 3, j is 4, right? So that simply means S2 is completed, right? Now what I'm doing here, if I don't need to delete any remaining characters, okay, from here, then the value is going to be 0, right? But if I just need to delete e, then value is going to be 101, right? If I need to delete both t and e, right, j is exhausted, and let's say here I need to delete the remaining number of characters te, so then ASCII value is e101 plus t is nothing but 116, so I will get 217. Same way for ete, okay, if all these are remaining portions, if let is the remaining portion, if elete is the remaining portion, if complete delete is the remaining portion, j exhausted, and here I'm still here, right? So these are the base cases I'm writing like this, right? Same way here in this case, let's say in S1, right, I'm at the end, right? I have exhausted my S1. Now in S2, if I don't delete anything, 0. If I delete t in the end, or if I delete et, or if I delete eet, or if I delete leet, then what are the ASCII values? So this is how I'm going to fill this DP table initially for the base cases. Clear this part, right? Now once this is done, okay, this is bottom up approach, right? So you have to first let's say we have this DP table, okay, this DP table. So we are filling the table bottom up, right? So here what is your I value? I is from if you see here, uh, I is starting from, right, I is 6, right? So 0 1 2 3 4 5, right? 6 is the end case, right? So here you have this delete, right? So you have 0 1 2 3 4 5, and then 6 is outbound, right? So here I am in DP, I'm going to create 0 to 6 number of rows, right? So here let's say 0 1, okay, and here how many I'm getting? 0 1 2 3 4 5, one more, okay, it fits, right? Now it's good. 3 4 5 6, okay, this is what I'm doing here. And j is for 0 1 2 3 4, okay, it's total 5. So here I will fill j's, right? Let's say here like this, 0 1, then 2, then 3 and 4, right? Clear? 0 1 2 3 4, okay, so these are my j's. So here let's say 0 1 2 3 4, right? So now here if you notice, I filled these things, right? So this is nothing but j is fixed, right? Last row I is equal to 6, okay, this 6 is fixed here, and j I'm taking, okay, so this is nothing but 6 4, right? 6 3 6 2 6 1 6 0, right? These are j values, right? So I will fill this, right? So here can I fill? Okay, it will take time, but okay, let's do one thing now, little bit let's see. This diagram is not very big, okay. So here 6 4, okay, 6 4 is 0, 6 and 4 is 0, right? So here I will fill 0, okay. Now 6 3 is 116, okay, so this is 116, right? And then here 217, this is 217. Then after that we have here 318, 318, and 60 is nothing but 426, okay, 426, 426. This is what I filled a base case, right? And same way here, if you notice, this j is fixed, right? This j is fixed, I is 6, so 6, this 0, right? Then 101, right? 6 5 5 4, so 5 4 is 101, right? 5 and 4 is 101, okay, this 101, right? And then after that 217, right? This is 217. Then here 318, 318, then 426, then 527, right? And then you have 6 to 7. Okay, these are the base things that we have filled, right? Now using this I have to fill, and in the end when I'm going to reach here, so we have delete, we have lead, right? So when my I is starting from here from 0 and my j is starting from here 0, so that's simply 0 to end and 0 to end here. So whatever the best result at this particular position I will store here. So that's what I need to return. So this is nothing but your bottom up type approach, right? So here now see here we have to fill this table. So we move from the bottom right to the top left. So I is equal to 5, right? And here j is equal to 3 2 1 0 I have to fill, right? So here if I just give the index 0 1 2 3 4 0 1 2 3 4 5, okay, 0 1 2 3, all right. So now here this base things I have filled. Now what I'm saying here, my I is at 5, right? I is 5, right? I is here, and when my j is at 3, okay, so these two I have to check, right? E and t both are not matching here, right? So maybe I can delete e or maybe I can delete t, right? So if I delete e, right, so now again you have to note the ASCII values, right? So here we have ASCII values with us, right? So if I delete e, so I'm going to get 101, right? If I'm going to delete t, I will get 116, right? So only these two I have to delete, right? 116 and 101, right? And here if I'm going to delete this, right? So if I'm going to delete this, so I'm going to check I plus 1 and j is going to remain same. But if I'm going to delete this, so I is going to remain same. This j, I is going to remain same, but j is going to move forward, right? So these two answers I need to check, right? So if I'm deleting this I, right? If I'm deleting this I, so e value is 101 plus this, or if I'm deleting this t, so t value is nothing but 116, right? So 116 plus this, right? 116 plus this, right? Okay, so 101 plus I plus 1 and j value I already know, right? So what is this I plus 1? So I and I is 5 here, right? So I is going to become 6 and j is what? J is, let's say, 3. Okay, j is 3, right? So j 5 comma 3, so 5 and 3 5. uh, Now I'm incrementing, right? So here I am 5 at 3. Now I have to check here I plus 1, that is nothing but 6 comma 3. So 6 comma 3, what is the value? So 116. So see here 116 I'm getting. Okay, same way here in this case, if you see, right? So we are 5 and 3. Now I'm just moving j, right? So 5 is going to remain same, j is going to become 4. So 5 and 4 values 101, right? So this is 101 here, right? So among them, whatever the best answer, 217. So 217 I'm feeling, right? Same thing here, I have to check then 116, right? So e versus e both are matching, then simply copy the value, right? So of 6 and 3, because 5 and 2 is matching now. So I told you if both are matching, then simply I move I forward and j forward, right? This is what we were doing in the recursion memo, right? So I'm simply copying 6 3 value. 6 3 value is nothing but 116, right? Same way 217 I will fill here, then 325. This is how you need to fill, right? Okay, so you can just go over these examples. I is equal to 3, right? Then I is equal to 2, then I is equal to 1, then I is equal to 0. Then in the end, whatever the best value, it will be here. Okay, so this is nothing but your bottom up approach, right? DP approach, this tabulation type, right? So this, I'm just going to make the changes in this code. Okay, I'm not going to implement any new thing here, right? So what I'm going to do, I'm going to remove this, right? Clear this part. And here I'm going to do one thing here. I'm going to put this here, and instead of memo, let's say dp, right? You can give any name, right? But let's say I'm giving dp, right? And here, see, I'm creating one bigger size right here. Here j is equal to 4, right? So 4, one more size I'm creating for j, right? So total 4 size, so I'm creating total 5 columns, right? 1 2 3 4 5. Same way here, total length is 0 1 2 3 4 5 6 is the length. So here I'm getting 6, right? But in 1 2 3 4 5 6, right? So total 6 length, but I'm creating 7 columns, right? 7 rows, 1 2 3 4 5 6 7. Okay, so that is why here I'm writing n plus 1 and m plus 1. Okay, this thing is clear. Now I'm going to delete these two things, right? And here base case, right? We have to write the base case, right? So here I will write base case. Base case means nothing but delete all remaining characters, right? So this first thing, delete remaining characters, right? If one is exhausted and other value, right? So here what I will do, int I is equal to, I'm starting from n minus 1, and here I is greater than equal to 0. I will do, right? I is greater than equal to 0, and here I will do just I minus minus, right? And here I am going to fill the values of dp of I and m, right, with dp of I plus 1, right, and here m and plus s1 dot char at I, right? So this is what I'm doing here, right? This is how, right? 101, then t is nothing but the combination of this new TSK value plus previous value. Then if I'm adding e, so e plus the previous this, right? So this is what I need to do, right? So this is one, right? We have to fill these two, right? This and this. Okay, so here I'm again going to paste it. Okay, and here this time let's say j is nothing but it is starting from m minus 1, right? M minus 1, and here j is greater than equal to 0, and here j minus minus, and here dp of, here I and m is fixed. Now this time here n is going to fixed, and here this time j is going to change, right? And j, and here same thing, here you have to write n, and here you have to write j plus 1, right? And here s2 dot character add j. Okay, this is what I need to do, right? And then I have to fill the dp table, right? So how I'm going to fill the dp table, that is also going to be very easy, right? So here first I'm going to run this loop. Okay, I'm going to run this loop. Now inside this I'm going to run this. Okay, bottom, from bottom I need to start, right? Okay, so I have this white colored already filled. Now I have to start from here, then here. Okay, like this. So I have to fill, right? So I is starting from n minus 1, and j is also starting from m minus 1. Okay, like this. Now here inside this, what I need to do, I will check if s1 dot character at I both are matching. Then in that case, okay, if both are matching, right? If both are matching, then in that case, what I need to do, I need to update my dp of I and j with nothing but both are moving, both are going to take I plus 1, right? And here j plus 1, right? And we already know these values, right? Okay, this part done. Now else, okay, else what we need to do, we have to delete one and take other, right? This is what we used to do, right? So here I'm just going to do what, dp of I and j, I'm going to update. Okay, I'm going to update it with math.min of, okay, so what I need to do, math.min, right? Math.min of, and here instead of this dfs I plus 1, right, I will simply write here dp of I plus 1 and j, right, whatever the value that I'm going to get here, or dp of I is going to remain same, and here j plus 1, right? This is what I need to do, right? Clear this part? Okay, and this ends here. And in the end I told you that what we need to do, we have to, this ends here, right? This ends here, this ends here, right? And in the end I told you that we have to return the value at dp of 0 and 0. That's it. This is your code, right? This is your code. And here you need to just remove this extra part. Okay, so this extra part ends here, right? That's it. Only 25, 27 lines of code, right? Okay, see, that's it. Okay, so very small, right? This code now dp1, only few lines of code, around 23. Okay, so if I'm moving this now, if I'm moving this forward, dp of I plus 1 j, right? So I'm deleting I character, right? So here, why I'm not writing s1 dot char at s1 dot char at I, and then this, right? This is what I need to do, right? Only then I'm moving forward, right? Same thing here, I have to delete s2 dot char at j, and then I'm moving j forward, right? Okay, now that's it. Okay, now let's run it. Done. Now let's submit it and see. So see, our solution is submitted again, right? And again, the time processed is going to be m into n, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.